You have now completed the introductory section of this course on cybersecurity and DevSecOps. Before moving on to more technical and specialized content, this chapter serves a double purpose, consolidating everything you have learned so far and giving you a clear personal checklist to verify that you are genuinely ready to progress. Think of this as your first professional milestone in a career transition toward becoming a cybersecurity and DevSecOps specialist. Let us start with a structured summary of the key concepts you have encountered throughout this introductory section. What DevSecOps actually means and why it matters. DevSecOps is the practice of integrating security at every stage of the software development and delivery process, rather than treating it as a final verification step done just before a product goes live. The name itself combines development, security, and operations, emphasizing that all three domains must work in coordination. Traditional software teams often relied on a separate security team to check the product at the end of a cycle. This approach created bottlenecks, late-stage discoveries of critical flaws, and costly fixes. DevSecOps breaks this model by embedding security checks, tools, and responsibilities throughout the pipeline from the very beginning. You have explored how this differs from classic DevOps, which focuses on collaboration between development and operations teams to accelerate delivery. DevSecOps adds the security dimension without slowing down delivery, quite the opposite. By catching vulnerabilities early, teams avoid the much more expensive and damaging cost of fixing them in production environments where real users and real data are at risk. A concrete example to illustrate this: imagine a developer writes a piece of code that stores user passwords in plain text. In a traditional model, this flaw might not be discovered until a security audit weeks later. In a DevSecOps model, an automated static code analysis tool embedded in the pipeline would flag this issue within minutes of the code being submitted, before it ever reaches a test environment. The CIA triad applied to pipelines. One of the foundational frameworks you have studied is the CIA triad: confidentiality, integrity, and availability. These three properties define the goals of any security effort. Confidentiality means ensuring that information is accessible only to those who are authorized to see it. In a pipeline context, this translates to protecting secrets such as API keys, database credentials, and certificates. If these are accidentally committed to a code repository, they become accessible to anyone who can read that repository, leading to a serious breach of confidentiality. Integrity means ensuring that data and software are not altered in unauthorized ways. In a pipeline, this means verifying that the code you deploy is exactly the code that was reviewed and approved, with no tampering in between. Mechanisms like cryptographic signatures and checksums help guarantee integrity throughout the delivery chain. Availability means ensuring that systems and services remain accessible when needed. Attacks such as distributed denial of service target availability directly. A secure pipeline must include measures to ensure resilience and rapid recovery, not just protection against data theft. You applied these concepts in quizzes and workshops, linking them to specific stages of a software pipeline. This grounding is essential because every security decision you will make later in the course can be traced back to one or more of these three properties. Security checkpoints throughout the pipeline. You have learned that a secure delivery pipeline is not a single gate but a series of checkpoints, each serving a specific purpose. Here is a summary of the main types of controls and where they appear. At the code writing stage, developers use secure coding guidelines and rely on tools that analyze source code statically, meaning without executing it, to find known patterns of vulnerabilities such as improper input handling or use of deprecated cryptographic functions. This type of tool is called static application security testing. At the dependency management stage, teams verify that the external libraries and components they use do not contain known vulnerabilities. This is called software composition analysis. For example, if a project depends on an open-source library that was found to have a critical authentication bypass flaw, software composition analysis would alert the team immediately when the dependency is declared. At the testing stage, automated tools simulate attacks against a running version of the application to find vulnerabilities that only appear when the software is actually executing. This is called dynamic application security testing. At the deployment stage, container images and infrastructure configurations are scanned to ensure they follow security hardening standards. A container that runs processes as the root administrator user, for example, represents an unnecessary risk that a security scan should catch and flag. At the monitoring and operation stage, logs and events are analyzed continuously to detect suspicious behaviors in production, enabling rapid response when something goes wrong. In the workshop where you adapted a secure pipeline for an e-commerce project, you applied this logic concretely. You identified which checkpoints were most critical for that specific context. For instance, protecting payment data requires particularly strong controls on confidentiality and integrity. The security-oriented user story. In your mini-project, You practiced writing a user story with a security perspective. A user story in software development is a short description of a feature from the point of view of the end user. A security-oriented user story adds an explicit security requirement. For example, as an online shopper, I want my session to automatically expire after 15 minutes of inactivity, so that someone who gains access to my device cannot use my account. This kind of thinking, expressing security as a user need rather than a technical afterthought, is central to DevSecOps culture. It makes security requirements concrete, testable, and understandable by all stakeholders, including non-technical ones. The storyboard. Incident avoided with DevSecOps. The storyboard activity illustrated a realistic scenario where a vulnerability was caught at the pipeline level rather than in production. This scenario demonstrated the practical value of everything you have studied. A developer introduced a flaw that allowed unauthorized access to user account data. Because an automated security check was part of the pipeline, the flaw was detected before the code was merged and deployed. The result: no data breach, no regulatory fine, no loss of customer trust. This kind of outcome is the core business argument for DevSecOps investment. Your personal readiness checklist. Now, use the following checklist honestly to assess where you stand before moving forward. Each item corresponds to a concept or skill covered in this introductory section. If you find yourself uncertain about any point, revisit the relevant activity before continuing. I can explain in my own words what DevSecOps is and how it differs from DevOps alone. I can describe the 3 properties of the CIA triad and give one concrete example of each in a software delivery context. I understand what a continuous integration and continuous delivery pipeline is and can name at least 3 stages where security checks can be inserted. I know the difference between static application security testing, dynamic application security testing, and software composition analysis, and I can explain what each one is designed to detect. I can explain what a pipeline artifact is and why protecting artifacts matters for security. I can write a basic security-oriented user story for a common web application feature. I understand why security must be integrated early in the development cycle rather than applied only at the end. I can describe at least one realistic scenario in which a DevSecOps practice prevented a security incident. I am familiar with the concept of a secure delivery chain and can list at least 4 components it typically includes. I understand that cybersecurity is not a single tool or action, but a continuous process requiring coordination between developers, security specialists, and operations teams. If you can confirm all 10 points on this checklist with confidence, you are genuinely ready to enter the more technical content of this course. If 2 or more points remain unclear, do not rush. The concepts introduced in this section are the foundation upon which everything else is built. A shaky foundation will make the more advanced material much harder to absorb. Why this matters for your professional goal. As a future cybersecurity and DevSecOps specialist, your role will involve understanding the full life cycle of a software application from a security standpoint. You will need to communicate with developers about secure coding, with operations teams about deployment hardening, and with business stakeholders about risk and compliance. The vocabulary, frameworks, and ways of thinking you have developed in this introduction are the starting point for all of that. In the upcoming sections of this course, you will go much deeper, learning to use tools such as Nmap for network reconnaissance, Wireshark for traffic analysis, and Metasploit for controlled exploitation in authorized environments. You will learn to conduct full penetration tests on web and application programming interface targets, produce professional vulnerability reports, and implement the components of a secure pipeline using real tools and real code. All of that advanced work will make more sense and be easier to apply because you now have a solid conceptual foundation. The introductory section was not just theory for its own sake. It was the professional framing that will allow you to act not merely as a technician who runs tools, but as a specialist who understands why each action matters and how it contributes to a genuinely secure system. Take a moment before moving on. Review your checklist. Be honest with yourself. Career transitions in technical fields succeed when learners build on solid ground, step by step, rather than rushing ahead and accumulating gaps that become obstacles later. You are at the entry ramp. The road ahead is demanding but entirely achievable with the right preparation.